In this video, we'll cover how bbr.bayes and other packages are used to diagnose the Markov Chain Monte Carlo, or MCMC, performance of non-mem Bayes models. Note that here in this Expo, we make a distinction between MCMC diagnostics and the more typical goodness of fit diagnostics we'd also use for non-Bayesian models. So after running a non-mem Bayes model, as demonstrated in the previous model management video, we look at a number of diagnostics to see if the MCMC sampling was adequate. Again, please refer to the tutorial paper from CPT PSP for a more complete description of these. But here, we'll walk you through how we generate them using these R packages. As we saw in the model management video, we can use the readFitModel function to return a draws array object. And this gives us access to a plethora of functions from other packages like subset draws and summarized draws from the posterior package that we see here. And this gives us a quick numerical summary of MCMC performance. We can see that for these parameters, the R hat values are all close to 1, suggesting good mixing between chains. But some of the effective sample sizes, or the ESS values, are quite low, particularly for theta 5 here, which represents the intercompartmental clearance in this model. We can also use functions from BayesPlot to work with these draws directly. So we can pass them into, for example, MCMC R hat to visualize the R hat values, and into MCMC and EFF, number of effective sample size, to look at the ESS ratios. And these plots together, again, make a clear point that our mixing between chains is doing well based on the R hat values, but looking at the ESS ratios, sampling is quite inefficient, particularly for some of the parameters. Again, we see theta 5 is the worst performing here. And in fact, if you go back to our model management demo page, you'll see that we attempt to address this for this example by switching from the default Metropolis Hastings and Gibbs samplers to the no U-turn sampler using the NUTS method in non-mem. The Bayes plot package can also be used to generate trace and density plots for these posterior samples for further evidence of the need for better sampling in this model. You can see the sampling inefficiency in these trace plots here, but at least the density plots show pretty good mixing. And then finally, in this example, we look at bivariate relationships between estimates using the MCMC pairs function from the Bayes plot package, where we thankfully do not see a high degree of correlation between parameters. In the next video, we'll switch gears to the model diagnostics page, where we'll discuss the goodness of fit diagnostics that are more typical of non-Bayesian models, but require some special handling for Bayesian models.